Fifth question. The bond dissociation energies of X2, Y2 and XY are in the ratio 1:0.5:1. Delta H for the formation of XY given. Bond dissociation energy of X2 will be. Bond dissociation energy of X2 will be. How to calculate? Delta H formation of XY is given. So it is half X2 plus half Y2 giving XY. This value is given minus 200. Okay. Now bond dissociation energies X2, Y2, XY in the ratio. The bond dissociation energies are in the ratio X2, Y2 and XY. It is 1:0.5:1. So suppose the bond dissociation energy, this is X, this is X by 2 and this is X. Okay. Now, in the the bond dissociation energy of X2. X is what we need to find out. We need to find out X, right? Now you apply the equation. Delta H of reaction is equal to sum of bond enthalpy of reactants minus sum of bond enthalpy of products. What is that? Bond enthalpy of reactants, X kilojoule per mole. For half mole, it is X by 2. X by 2 kilojoule per mole. For half mole, it will be X by 4. This is reactants. Minus that of product, X. And this is equal to minus 200. Find out X. So X by 2 plus X by 4 minus X is equal to minus 200. Find out X. And you can easily work out X as 800 kilojoules. You can easily work out X as 800 kilojoules. That is option 1. Simple calculation. I am not spending the time. Simple calculation. So I'll repeat. Their bond enthalpy in the ratio 1:0.5:1. So if this is X by 2, this is X. Okay. Now, the enthalpy of reaction given minus 200 and that is equal to sum of bond enthalpy of reactants minus that of products taught in the classes. So what do? Sum of that of the reactants, X kilojoule per mole for half mole X by 2. X by 2 kilojoule per mole for half mole X by 4. And you add that and subtract with X, you get minus 200, find out X. Okay.